In this lecture,
we'll be discussing about
structures of operating system. So in one of the previous lectures, we already discussed about something called operating system structures, where we discussed about multi-programming and multitasking operating systems. So those were two types of operating systems. But in this lecture, what we are going to discuss is about the actual structure of operating systems. So we know that operating system is a large and complex system, and it has to be engineered carefully so that it will function properly and it can be modified easily. So there are different structures that have been followed from the beginning till now, using which the operating systems have been designed. So we will be discussing about some of those structures, and we will see the advantages of those structures and also the disadvantages of those structures. So first of all, let us go to the first structure that was followed in designing operating system, which was used in the very beginning, and also the olden operating system, which we call as the simple structure. So the simple structure was the structure that was followed for most of the operating systems that were designed in the very beginning. And this simple structured operating system did not have a very well-defined structure, because it was operating systems. Those were designed in the very beginning. So the diagram that we see here, this is the figure of a simple operating system structure that was followed by the Microsoft Disk Operating System MS-DOS. So we know that MS-DOS was an old operating system which was designed very long back. And this is the structure, or the simple structure, followed by the Microsoft Disk Operating System. So here at the bottommost, we have the ROM, BIOS device drivers. So think of this as your base hardware. And then on top of this, we have the device drivers. Then we have the resident system programs, and then the application programs. So we see that the device drivers, they have access to this basic hardware. And we see that the resident programs, they have access to the device drivers, as well as to the basic hardware. And then even the application programs, they have access to the resident programs, as well as the base hardware. So we see that the base hardware can be accessed by all the things above it. The device drivers, system programs, application programs, everything can access the base hardware. So we see that in this structure, the interfaces and levels of functionality are not well separated. So we see that application programs are able to access the basic input-output routines and a ride directly to the display and the disk drivers. So that means application programs are able to access your base hardware directly without going through this layers below it. So this looks like they are kind of a layered structure, but we cannot call it actually a layered structure because there is another structure of operating system called a layered structure, following a layered approach, which we'll be discussing as we move on in this lecture series. And we will see how it is different from this one. So even though this looks like a layered structure, this is not actually a layered structure because all these layers have access to the base hardware. So what happens is that such freedom leaves the MS-DOS vulnerable to errand or manages programs, causing the entire system to crash when the user program fails. That means if you are running a program here, if an application program is being run by the user, and since it is directly accessing this base hardware, if that program fails, then that entire system is going to crash, because it is having direct access. So we see that it is not well protected, it is not well structured, and it is not well defined. So this is not a very good structure. And also we cannot blame the developers or the designers for designing this because, as we are talking about the MS-DOS operating system, MS-DOS was actually written on the Intel 88, and this Intel 8088 does not provide dual mode or any hardware protection. So the developers or designers, they had no other option than to just leave this base hardware accessible by all the layers above. So that is why it is like this, and we see that this is not efficient, and this is not a good structure. All right, now let us see another structure known as the monolithic structure, which is also kind of a simple structure. Now another structure that we see is known as the monolithic structure, and this was followed by the earlier Unix operating systems. So in this minority structure, this also is a limited structure. And why is that? We'll see it. Here we have the kernel, and then the system programs. So here on top we have the users, and below that we have the shells and commands, compilers, interpreter, system libraries, and so on. And below this is the system call interface to the corner. That is the system call which access interface to the corner. And this part is the corner, alright. Everything below this system call interface to the corner and above the hardware. This bottommost part is the hardware, so everything above this hardware and below the system call interface with the corner, this is known as the corner. And in the corner, it has all these functionalities like signal, terminal handling, character input, output system, terminal drivers, file systems, swapping block input, output systems, disk and tape drivers, then SIBUSH, dueling pace, replacement, demand paging, virtual memory, and so on. So everything is actually packed into one level. And hence we call it a monolithic structure. So this was followed by the earlier unique systems. So in here we see that everything, all these functionalities, are packed into one level, which we call as the kernel now. The problem with this is that there are too many functions packed into one level, and this makes its implementation and maintenance very difficult. So let's say that you want to add something to this, then you have to change this entire thing, or you have to modify this entire thing. Or let's say that you want to debug a certain functionality in this kernel, said that there is a problem with your CPU scheduling. So in order to fix that issue of CPU scheduling, you will have to touch this entire kernel. So this makes it a system that is difficult to be maintained and implemented right. If you want to add something to it, also it is going to be difficult. So this is the disadvantage of the monolithic structure. There are too many things packed into one level. So this is also a simple and limited structure, followed by the earlier operating systems, like the earlier Unix. So now we have talked about two simple structures. The first simple structure from Microsoft Doors, and the next monolithic structure from Unix. So we saw that both of them were having some disadvantages. So in order to sort that disadvantage, they came up with another structure called the layer structure. So in this layered structure, your operating system is divided into a number of layers. Like for example, here at the lowermost level, or at layer 0, you have your hardware. Then you have layer 1, layer 2, up to layer N. The topmost layer is the user interface. So here, in contrast to the monolithic system that we just saw above, where everything was packed into a single level, here we have broken down the functionalities into different layers, and we have separated them like this. So the main advantage of this is that it is easy to implement and debug this one. Why? Because every layer is having different functionalities. So instead of keeping all together, we have divided them into layers. And let's say that one layer is having a problem. Let's say that the CPU scheduling is again having a problem. So in order to debug that, we just have to look at that layer and debug that layer instead of going and digging into the entire operating system. So this is one of the advantages of this layered operating system. But again, we can't say that this layered approach is the best, because it also has its own disadvantages. Like for example, let us talk about some of the negatives of this layered structure. So one difficulty is in designing this layered structure, because you have to be very careful and specific in designing and deciding which will be the layers on top of a certain particular layer, or which will be the layers below a particular layer, because a layer can use only those layers which are below that layer. Only the services by the layers below it can be used by a particular layer. Like, in order to make this clear, let me take an example. So let's say that we are having a layer which deals with the backing store. That means the layer which deals with disk space used by the virtual memory algorithms. So there is a layer dealing with the backing store, or the backing storage. Now this layer, we have to make sure that it has to be below the layer that deals with memory management, alright, because the memory management routines needs to use the services provided by the backing storage. So because of that, we have to make sure that the backing storage layer is below the memory management layer. So this is just one example, and in that way, there may be so many other requirements which may not be so obvious. So we need to be very careful in designing this. So this could be one problem. In this, another problem of this layered structure is dead. This may be not very efficient as compared to the other structures. Why that is? Because when one layer wants to use the services provided by the layers below it, the request has to go down below each layer, one by one, and by the time the service is actually provided. It may be late. It may not be very fast. Like, let's take an example. Let's say that a user program from this layer N, it wants to execute and output operations. So in order to execute the output operation, it has to get the service from this layer 0 because output devices are falling under this hardware. So what it will do, it will issue a system call. So we have already discussed our system calls. So this layer will issue a system call in order to use the hardware. So the system call has to go through all these layers one by one, and it has to reach this layer 0. So as a system call passes through these layers, the parameters of the system call may be modified, and it will take time in reaching here. And then once the system call is granted, then it will be able to use the input-output devices. So we see that as it has to pass through all these layers one by one. It is not going to be very efficient by the time it actually gets the input-output operation as it was requested. It is going to take some time. So that is one of the major disadvantages of this layered structure. Alright, so here we have seen the advantages of layered structure and disadvantages of layered structure. One major advantage is that the hardware is protected from the layers above. Unlike the simple structure, the user interface cannot directly access the hardware. We see that it is protected because of all these layers above it. So that is one of the advantage, and we have discussed what is the disadvantage of this layered structure. Now coming to the next one, we have something known as microcorners. So this is another structuring operating system. Now in the monolithic structure, we saw that so many things and so many functionalities were packed into the kernel, making the kernel very big, bagged with functionalities. But in this microkernel approach, what happens is that we are having a microkernel. Micro from name itself, we know micro means it is something small. So instead of a big kernel with so many functionalities, what happens is that in this microkernel approach we remove all the non-essential components from the kernel and we implement them as system and user level programs. So here, the microkernel, what it will do, it will just provide the all functionalities of the kernel, and then the other functionalities which are there, like the device drivers, the file services or the file servers, process servers, virtual memory, all the services, they are implemented as a user level or system programs. So they are on top of this microkernel, implemented as some kind of system programs. So the main function of this microkernel is to provide a communication between the client program and this services. Alright, so there is a client program requesting for some kind of services. So in the monolithic approach, what happens is that the client program will have to ask the service from the kernel, because everything is there in the kernel, and then from the kernel it has to get services. But in this microkernel approach, the client program will request something, and the microkernel, what it will do is it will just provide the communication between the client programs, and it will just help them to communicate to these services, which are implemented as system programs. And in the communication between the client programs and these system programs, which provide the services, are made to with something known as message passing. So message passing is the thing that we use for communication, and we will discuss message passing in detail when we move ahead in lecture series. So again, the advantage of this microkernels is that we see that this most of the functions which are there will be executed in user mode because the kernel is having only the core functionalities. So when the client program wants to access any of the services, it does not actually have to be run in kernel mode. It can be run in user mode because most of the services are there as a system program. Now we already discussed user mode, kernel mode in the previous lectures. So if a program is executed in user mode, even if that program crashes, the entire system is not going to crash. But if it is running in kernel mode, if that particular program fails, then the entire system is going to crash. So a microkernel approach, since most of the functionalities will be run in user mode, the crashing problem of the entire system is not going to happen mostly. So that is advantages of microkernel approach. But again, this also has its own disadvantages, like microkernels can suffer from performance decrease due to the increased system function overhead, because, as I told you, we are using message passing, which helps in communication of the client programs and this services over here. So since that communication has to be done always, there could be a system overhead leading to a decreased performance. So this is another disadvantage of this microconus. So that is the concept microcorners, and we saw how it is good, and also what are the negatives of that. All right. Now coming to the last one, we have modules. Modules means we follow a modular approach in the structuring the operating system, and this by far perhaps is the best current methodology for operating system design, which involves using object-oriented programming techniques to create a modular kernel. So here, what happens? We have a core kernel, and then this core corner will have only the core functionalities of the corner, and then the other functionalities are present in the form of modules, which will be loaded to the kernel either at boot time or at runtime. So there are some functionalities like the device and bus drivers, scheduling classes, file systems, loadable system calls, executable formats, stream modules, and miscellaneous modules. So these modules will be dynamically loaded to the kernel as and when required. So this is how the modular structuring works. So if you look at this modular approach, it looks something like the layered approach, and also it looks a little bit like the microkernel approach. Let's see why, and let's see how it is actually better from those two. So it resembles the layered system in such a way that each corner section has defined protected interfaces. Each of the layers have a defined protected interfaces, which is protected from the things that we don't want them to access. But it is more flexible than a layered system in that any module can call any other module. So in the layered approach, we saw that when one layer wants to communicate to another layer, it had to go through the layers all above it. Like for example, we have already seen if let's say that layer 1 wants to communicate or use some services from layer 4, then it has to go through layer 2, layer 3, then reach 4. But in this modular approach, even though it looks like the layered system, it does not have to go through those layers. Each of the modules can communicate to the other modules directly through the core corner. Let's say the file system has to communicate the device and bus drivers, so it can directly communicate like this. All right. So that is the advantages and flexibility that is offers as compared to the layered approach. Even though it looks like the layered approach, so though it looks like the layered approach altogether, but it is more flexible, better than the layered approach, and also it looks a bit like the microcanal approach we just saw before this. So in the microcanal approach, what we had the kernel, the microkernel, which have only the core kernel functionalities, and then the other functionalities were provided as system programs above that. So here also we are having the core kernel with only the core functionalities, and then the other functions are loaded into it whenever necessary. But its advantage as compared to the microkernel approach is that in microkernel approach, we need to have message passing in order to communicate between the modules, because they are implemented as system or user programs above the corner. But in this one, they are loaded dynamically directly into the core corner as and when needed, so they don't need to use that message passing, and hence the system overhead is nor there. So that is advantages of the modular approach as compared to the layered and microkernel approach, though it resembles them in some areas. So we can say that by far this is one of the best structuring of the operating system that we can have and is used by most of the operating systems. So those were some of the structures of operating systems. So we discuss about the simple structure, the monolithic structure, the layered structure, the microkernel approach, and then the modular structure. So these are the structures of operating system, and I hope this was clear to you. Thank you for watching, and see you in the next one.